Hello everybody. For this week's tutorial, I'd like to go over the mechanics of your voice, as well as how sound is produced mechanically, and how it can be classified as either a string instrument, a percussion instrument, or a wind instrument, which vocals are a part of. The first part of how your voice works is that your lungs generate airflow. So as long as your lungs are able to properly supply enough air, it will travel through your vocal cords and out of your mouth. And for very loud tones, you would have to use up more of your lung capacity. So you'd most likely run out of breath quicker than if you talked or sang at your normal volume. Once your lungs generate the air supply, it goes up to your larynx, which is more commonly known as the voice box. And the vocal folds on the inside edges of your neck are what vibrate to give you your voice. When you change pitch or volume, the larynx adjusts the tension of the vocal folds. Although different voices have different ranges in terms of pitch, because everybody has different thicknesses and lengths of the vocal folds. Although generally, men have thicker and longer vocal folds, which means their range is much deeper than women's. And this is most obvious at their natural speaking frequency, instead of when they're trying to sing different notes. And the final part, besides the vocal folds, that determines the quality of your voice, is the shape and size of the empty space in your mouth and nose, formerly known as the oral and nasal cavities. Because when you speak, the throat expels air out both your nose and mouth, and not simply your mouth, as you might initially think. So if you were to plug your nose so that air would not be able to flow out of it easily, it would sound like this. And if you were to try to lock your tongue in a certain place instead of letting it move freely like normal, it would sound differently depending on which place you would hold your tongue in. So if you locked your tongue to the top of your mouth on the inside, you would sound like this. And if you were to lock your tongue to the bottom of your mouth instead, it would sound like this. And if you were to try to keep your tongue held in the corners of your mouth, aka the cheeks, it would sound like this. So as you can tell, you can experiment with keeping different parts of your nose and mouth open and closed to get different sound types, as well as working on your throat to make sure that you get the correct pitch that you wish, and your lungs to make sure that you get the correct amount of volume that you want without running out of breath. Now that we have gone over the mechanics of how your voice works, we can discuss the mechanics of the other instrument types: string instruments, wind instruments, which your vocals count as, and percussion instruments. A string instrument is made by fixating a string in two locations at their endpoints so that it is held firmly and tightly in place, and then plucking one part of the string so that it resonates. although it will eventually stop moving if you do not strike it again or find some way to keep it moving. Note that not any string will work with this. For example, although the cord that has headphones connected to the computer is most certainly a string, it will not work because the material is too firm and thick to vibrate if you try to pluck it. A similar principle happens if you try to pluck the charger for a laptop or phone. Because yes, even though that cord is a type of string, it is also too thick and durable to really vibrate that smoothly. So most of the time, musical strings, like you see on a guitar or violin, are very thin and made out of a material firm enough that it won't snap easily, but still flexible enough to vibrate. So most of the time, it is a straight steel or nylon wire that is used for guitar or violin strings, with nylon being able to vibrate more than steel, so it will create a more mellower sound. The next type of mechanical instrument, the wind instrument, uses a pipe or pipe-like object to concentrate the airflow, making a mellow, whistle-like sound. In fact, as you can imagine, this is exactly how the human voice works, because the throat is the pipe-like object, as well as the opening of the lips to the mouth. And you can generally control the pitch in a wind instrument by one of two ways, with valves inside the airway or holes on top of the airway, as well as how wide the opening is at the end of the airway. So even if you do not have a wind instrument with you, you can explore the final concept mentioned by opening and closing your lips into different shapes while you whistle. The last type of sound produced mechanically is the percussion instruments, which is the most simplest because it is simply striking something. However, some percussion instruments, like the maracas, are more creative in how they execute this striking, because the striking an instrument like that is the striking of the material inside it, rather than you striking the objects with your hand. However, for most percussion objects, the outside is struck with your hand or a similar object like a drumstick, rather than having something inside strike each other. As a general rule, the more tougher the material, the more forceful the strike is. So a metal on metal strike would be much more powerful and louder than human skin on metal or wood on metal. Note that although this might seem a strange way to think about it, sliding friction can also count as a type of percussion, like the sound you hear from rolling a ball across the floor or dragging your hand across the table. Because things are still colliding and striking with each other, it's just at a very small level than you would usually expect. There are also percussion instruments that will resonate and vibrate well after you strike them, such as a bell or a glass jar, because of the way they are shaped as well as the material. However, As you may be able to imagine, many sounds you hear in games, movies, or professional music records cannot all be made mechanically. So many times, it is made with electronically manipulating the sound instead of using one that is produced 100% mechanically. And we will begin discussing the most basic of these electronic effects next week. In particular, amplification, tempo change, pitch change, speed change, and fade in and fade out. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.